Hi, welcome back to SQL Database Administration Hub. Today, we're building a step-by-step process for diagnosing slow SQL Server performance. Someone calls you and says the server is slow. Where do you start? By the end of this video, you'll have a repeatable diagnostic framework you can apply every time. Let's get into it. One of the most common and stressful situations a DBA faces is the urgent call. The database is slow. Fix it now. Without a structured diagnostic approach, it's easy to jump to conclusions, chase the wrong problem, and waste valuable time. In this video, we'll build a repeatable step-by-step framework for diagnosing slow SQL Server performance, from the initial triage all the way to root cause identification. This process works whether you're dealing with a sudden performance spike or gradual degradation over time. The first thing to do when you receive a slow server complaint is gather context before touching anything. Ask these questions. When did the slowdown start? Is it affecting all users or specific users? Is it affecting all queries or specific databases? Has anything changed recently? Deployments, data loads, configuration changes, hardware changes? Is the server under unusual load today compared to normal?
The answers narrow your investigation significantly. A slowdown that started exactly when a deployment happened points to application or query changes.
A slowdown affecting only one database points to database-specific issues. A slowdown that correlates with unusually high user load points to resource saturation. Then quickly check your SQL Server error log for any errors or warnings that coincide with the start of the slowdown. In SSMS, right-click your server, go to Management, then SQL Server Logs, and review the current log. Error messages, failed jobs, and warning events often tell you immediately what went wrong. Check SQL Server agent job history. Did a maintenance job run at the same time the slowdown started? Did a backup job or index rebuild start unexpectedly during business hours? This context gathering takes only 2 to 3 minutes, but can save you from chasing the wrong problem for 30. Once you have context, quickly assess the 4 key server resources: CPU, memory, I/O, and network. Check Windows Task Manager or Resource Monitor for CPU and memory. Is SQL Server consuming near 100% CPU? Is physical memory exhausted? Are there other processes competing with SQL Server for resources? Then check wait statistics. This is your fastest path to understanding what SQL Server itself is waiting on.
Select top 10 wait type. From SysDMOS wait stats, where wait type not in, order by wait time MSDSC.
In 60 seconds, this query tells you whether you're dealing with I/O pressure, CPU pressure, locking, memory pressure, or something else entirely. This determines which direction your deeper investigation goes. Check Disk I/O using SysDM I/O virtual file stats to see if any database files are showing high read or write latency. Latency above 20 milliseconds for data files or above 5 milliseconds for log files indicates I/O is a bottleneck. Once you've identified the resource bottleneck, drill down to the query level to find what's driving it. If you identified CPU pressure, use SysDM execa query stats ordered by total worker time to find the top CPU consuming queries. If you identified I/O pressure, use SysDM exec query stats ordered by total logical reads to find queries reading the most data. If you identified blocking, use SysDM exec requests filtered for sessions with a blocking session. For whichever queries you identify, pull their execution plans, either from the plan cache using SysDM exec cache plans, or by running them directly with the actual execution plan enabled.
Look for the warning signs we covered in the execution plans video: table scans on large tables, key lookups with high row counts, large row count mismatches between estimated and actual.
If you have Query Store enabled, check the Regressed Queries report. A plan change is often the culprit behind sudden performance degradation that wasn't triggered by any obvious external change. Document everything you find: the wait types, the offending queries, the execution plans, the timeline. This information is valuable for preventing recurrence and for communicating your findings to application teams and management. And that's how you diagnose slow SQL Server performance step by step. To recap, start with initial triage to gather context, check the error log, and identify any recent changes that correlate with the slowdown. Move to a resource check using wait statistics and I/O DMVs to identify which resource is under pressure. Then drill into query-level investigation using the appropriate DMVs based on your resource finding. Pull execution plan. This framework is methodical, repeatable, and effective. Use it every time and you'll reach root cause faster, fix problems more confidently, and communicate your findings more clearly. Subscribe so you don't miss the next video, and I'll see you there.
Generous Academy.